Oh, there we go. Hi, everybody. Welcome. I see we've got Dalen, we've got Keke, we've got Lutando, and you need to change your name, Lutando. We've got Chuanello, we've got Camojelo, and we've got Ridwan. How are you all doing?
Good and you, sir?
No, I'm very well, thank you. What about everybody else?
I'm
You
good,
are-
sir.
That's great. And who is that? Ridwan. Yeah.
Thank you, sir.
All great, thank you. Let's see who else we have. We've got Mapaseka also. How are you doing, Mapaseka?
I'm good. How are you, sir?
Very well, thank you. Today we're going to be looking at 3D shapes. Are you all familiar with 3D shapes? Who's familiar with 3D shapes? Nobody? Dalen, what about you? Nope. Let's have a look in the chat. Oh, you are, Lutando. That's great. Yay. Okay, good. Thanks for that. So, who can tell me what are 3D shapes? Lutando, maybe you, since you understand 3D shapes. Maybe if you can tell me what are 3D shapes? Lutando? Let's see in the chat. Nope. Dalen, maybe you want to tell me what are 3D shapes? Also, welcome to everybody on the live feed. I hope you're all doing well. Lukwazi, do you want to take a try? What are 3D shapes? And how are they different from 2D? You can read on the screen. There is some info there. Three-dimensional. Okay, yes. So they're three-dimensional. If you look at the object, let's look at what we have on the screen. I'm going to make this a bit larger. Let's have a look. Whoops, what is that? Let's bring the pointer back. It says, remember, 2D shapes have a length and breadth, while 3D objects have length, breadth, and height. Okay, so it has a length, a breadth, and a height. So three-dimensional objects, you can see them from all sides. So if you have something that's three-dimensional, I wish I had a box with me right now. No, can't find one around me. But yeah, three-dimensional, you can see it from all sides, right? Whereas two-dimensional, you can only see it from the one side. So if you look at two-dimensional, like here's a three-dimensional object, right? So this three-dimensional, we don't know the sides, but it kind of looks to me like it is maybe a rectangular prism. So the 2D version of this would be a rectangle. So we get a rectangular prism, and the 2D version would be a rectangle, right? So let's look. So three-dimensionally, we've got a rectangular prism, whereas the two-dimensional version would just be the front part here, which is the rectangle, right? So let's write that down. So 2D, rectangle, And 3D would be rectangular prism. So 2D would be rectangle, 3D rectangular prism. Prism. The three-dimensional word, right? Prism. And remember 2D, we just have a rectangle, so it would just look like this. Sorry, I drew it freehand, but remember rectangle, opposite sides are equal, right? Okay. Is that okay, everybody? You can just message in the chat, or you can say thumbs up, or also unmute. Is this okay? That 2D is a rectangle, and 3D would be rectangular prism. Okay, thank you, Twanelo. Thank you, Nsaki. Thank you, Dalen. Okay. All right. Okay. Those of you that want to attempt to draw it's a bit tricky to draw this, but generally what you do is I'll just show you like a very quick freehand version. What you do, you draw a rectangle. So you just quickly draw a rectangle like that, right? And then you draw a line, another line there, down, and there. And then because it's three-dimensional, we can show the other parts with the dashed line like that. But I know some people do struggle drawing three-dimensionally, right? Yeah. How many of you struggle drawing the three-dimensional shape? Are there any of you? Swanello, you do? Okay. Yeah, it's very common. People do struggle drawing three-dimensional shapes. Swanello, you've got your hand raised. Do you have a question?
No, sir.
No, no.
I was just
Okay.
answering a question.
Okay, great. Thank you. Ridwan as well. You. Saripa, welcome. Tosley. Okay. So now we move on to that particular three-dimensional shape where we have a net. So we call this a net, N-E-T. So remember, like, you can take a piece of paper and you can measure boxes like this. So each box, say you measure it, this is 3 centimeters. So we can measure 3 centimeters, 3 centimeters, 3 centimeters, 3, 3, 3, 3, 3, 3, 3, 3 centimeters throughout, right? And how many boxes are there? Let's count how many. We have got 1, 2, 3, 4, 5, and 6. So we've got 6 boxes, right? What happens when you fold all these boxes? So you can cut it out with a scissor and you fold it. It is going to form a cube. Can you see here we have a cube? Saripa, we are doing three-dimensional shapes, eh? Three-dimensional shapes. How many of you have done this before? Drawing out a net, then cutting it out, and then making a cube. Who's done this? In class or just for fun? Who's done this? Dalen, you've done it. Lukwazi, Lutando. What about the rest of you? RR? Zumbewe. And then we've got Saki. That's great. Okay. Well, right. That's really good. And you've got 6. The one will be at the bottom, the base. So if I can label this, right, I'm going to clear this out. I'm going to label it, right? But remember this, it can be done differently, but I'm just going to label it like the way the way I see it. And then you might see it differently. So I'm going to color the base, right? Here's the base. The base is here. I'm going to color the base in here, right? There's the base, and then the side. That's the side. And then the other side here. Here. Then the top. And then the front and the back, right? Sorry, it is a bit messy, but I hope you're understanding what's going on. And that's the front. Okay, so yeah, we can just match all the sides. Are you all able to see this three-dimensional shape, like the different parts? Front, bottom, top, front, back, side, side. Wanga, is that okay? KK? Tosley? You able to see? Yeah, okay, great. Kamogelo, you can. Okay, great. Thanks for that. Kazimla, how are you doing, Kazimla? Is this section okay for you? You're welcome to unmute or type in the chat. Okay, great. Thank you, Kazimla. Thanks, Ridwan. Thanks, Chuanelo.
Yes, sir.
Great. Thank you. Thanks, Wanga. So this is what we call a cube. The previous one we called rectangular prism. This is what we call a cube, right? Cube has all four sides equal to each other. Okay. Okay, we call that a cube. Then we get a rectangular prism, which I'm going to show you as a net. Let me bring it in here. Here's a net of a rectangular prism. Okay. Can everybody see this? If you cut it out, it's going to form a rectangular prism, right? So we got the base, we got the top, the side, front and back. Okay? Yeah. Just have a look and see for yourself which parts are going to be the front, the back, the side, and then we can compare. Yes, Saripa, you're welcome to answer. Saripa, do you want to help me identify the different sides?
So the top is the one on the right, the far right, sir.
The top is the far right. Okay, so the one on the far right, let me label it. This is top, right?
Yes, sir.
Oh,
Then
wait.
the one,
Yes, carry on. Thank
then the
you.
one next to the top are the sides.
So this, let me shade the top in, right? So this is the top, right? Okay, then you say the one next to the top is the side. So this one is side, eh?
Yeah, also the one next to the base, sir.
Here, side, side, eh?
Yes.
And then what do we have?
And then we have the front and the back, the one which is on top and under.
Okay. So now it depends how you look at this shape, because I'm looking at it slightly differently. Because you're saying this one's the bottom, hey? Saripa?
Yes, sir.
And you're saying this is front and back, eh?
Yes.
Okay. Right. What does everybody think? Do you agree with the thank you, Saripa. Thank you for that. Do you agree with the way Saripa's designed this one, or do you think we should swap some of them around?
So that's okay.
It's okay. Okay. Anybody else? Yeah. Anybody else? Let's look at the chat. Mapaseka said it's okay. All right. Yeah.
Yeah, my nose.
It's okay. Yeah.
It's okay, sir.
It's okay. All right. Okay. So it all depends on how you're looking at the shape, right? Because we can put sides in there. Let's do this. Let's put numerical values, right? And then we can see what we can do further. It is not incorrect. However, there is other ways of looking at it as well. So let's put sides. So what will this be? This will be 7 centimeters. All these are 7 centimeters, right? And then we've got 4 centimeters. And then we've got 2 centimeters. Yeah, this can also help us to put everything together, right? And form the shape. So, yeah. If I look at the one that's 4x2, I'd say that's a side and side, and the one that's 7 centimeters by 4, that'll be the front and the back. And then the 7x2 will be the top and the bottom. Yeah. So to me, this looks like it might also be like this. So the 7 centimeters by 4, see 7 by 4 will be the front and the back. So here. Seven by 2 will be the top and bottom. And then here, this one will be side and side. So we can also look at it like that. Okay. Does everybody get the way I've done it here? Thanks, Swanello. Anybody else? Is this looking okay? Who else can tell me? We've got Asonge. Asonge, how's this? Kamogelo? The net. Are you understanding the net, Kazimla? Thanks, Lutando. RR. Thanks, Kazimla. Great. Okay, cool. All right. So let's break this down into different shapes. So we've got a front and a back. We've got a top and a bottom, a side and a side. So let's break it down into different shapes. So what shape is the front? Is it a square? Is it a rectangle? Is it a trapezium? Last week we learned a lot of two-dimensional shape. What is the shape in the front? Okay.
Rectangle, sir.
Rectangle. Okay. So the front and the back are both rectangles, correct? Okay. And they are 7 by 4. So this is front and back, right? Okay. Front and back is 7 by 4. Then we've got the top and bottom. What shape are those? What shape is the top and the bottom? Anybody? What's the name of that shape? Asonge?
Rectangle.
Rectangle as well. And it's 7 by 2. So this is top and bottom. And then we've got the side and the side, which is also a rectangle. Which is 2 by 4, right? Sides. So we've got front and the back, top and the bottom, side and side. So we've got 8 parts to this shape here. So each of these they multiplied by 2. We've got 8 parts to the shape, right? Okay. Okay, Fakir, is that okay?
Yes, sir.
Okay, great. So we've got cube, we did rectangular prism. What is left? What is the one that's left?
Triangular prism.
Triangular prism. Great. So let's look at that one, right? So we've got to do the triangular prism. Let me get that out. Okay, I've got the triangular prism here. Let's bring it in. So there we go. So we've got a triangular prism here. And you can see the base shape here is a triangle, right? We've got a triangle, and then we've got the sides, which are rectangles and other shapes, right? So we've got a triangular prism. Triangular prism. 3-dimensional triangle prism. Okay. So have any of you seen this shape before?
Yes, sir.
Where have you seen it?
Yes, sir.
Hey? The roof of some houses maybe looks like this, hey? Triangular
sir.
prism. Yeah.
Yes, sir.
You can maybe see some ramps. Some may look like this. You see this shape quite often. If you look around, you'll be able to see it,
As
right?
well as a camp tent.
The tent, yes. The camping tent looks like this as well. Okay. So we've got the shape and we've got a net here of this particular triangular prism, right? And the net, you can see once you assemble it, you're going to form the triangular prism, right? So we've got the net, we assemble it and we'll form the triangular prism. Okay. So let's look. We've got 2 triangles and we've got 3 rectangles. 2 triangles and 3 rectangles. Okay. So here's the 2 triangles. It's we could say it's front and back because this is it's a bit what do you call it, slanted. So we can say the triangles are the front and the back. So this will be front. This one is the bottom. And then we've got side and side, right? Okay, so we've got 5 parts to this shape. We've got 5 parts to this shape. Okay, and we can calculate the areas or the perimeters because we know exactly what the different sides are. So this looks like the slanted one is 5, so that's 5, 5, 5, 5, 7, 7, 7, 7. And what else? 4, 4. 5, 5, 5, 5. Yeah. Can you see how they all connect? This one will eventually join with that one. That one will eventually join with that one. These will join here. These will join there. And then the top parts will join. So this one will join with that one. Can you all see that?
Yes, sir.
Okay, great. So this
Yes,
is
sir.
triangular prism. Prism, 3-dimensional. Okay. Any other shapes that we have that we should do this with, like the nets and things? Anybody else? Hey,
Pyramid.
the
Pyramid.
pyramid. Okay, so we get a pyramid that we can do this with as well. So pyramid, we can get a pyramid, a base. With many triangles, right? Oh, I'm not very good at drawing this. So we get this, this, this. And we'd connect them all together, right? Please excuse my rough drawing, but this is an example of something we could just draw a pyramid. Eh? Does that make sense? So all the sides and the base. Eh? Yes, okay. Lots of different shapes. I see some of you are typing and sending through prisms of pentagons, hexagons. Yeah, all different shapes that we can make 3-dimensional, right? What about a cylinder? Cylinders can also be 3-dimensional. So we get cylinders. can also be three-dimensional. Okay, so cylinders, and it has a top and bottom. Some of the cylinders are open, some of them are closed. So cylinders can also be three-dimensional shapes. Eh? Hmm? Okay. Right. So I want to go back to some of the three-dimensional shapes and look at some calculations we could possibly have using them. But before I do that, I just want to find out how you're doing so far. Are you able to understand these? How's it looking? Any questions?
That's okay.
It's okay. Okay, great. Everybody else?
So it's okay.
All right. Everybody's finding it okay. Let's see. It's okay. Thank you. Thank you, Tuanelo. Okay. So remember, we can find the area, volume, surface area of the various different three-dimensional shapes, right? So I want to look today at just the area part and the surface area. So we're going to go back to the rectangular prism because this one is quite nice. Actually, we should start with the cube. Let's start with the cube, right? So here's a cube. Cube, remember, it's got how many sides? It's got 6 sides and they're all equal to each other, right? Is that right? 6 sides and they're all equal to each other.
Yes, sir.
Okay. Okay. So this one here, one side is 3. That means they all 3, 3, 3, 3, 3, 3, 3, 3, 3, right? So each of them would be 3. How do we calculate the area of a square? What's the formula? Anybody want to let me know? Area of square, who's done this? Let's have a look. Rory Sang, have you done this one? Asonge, was this?
Mausa, we
Arsene?
still had a
Sorry,
component.
Arsene. Who's this? Rory Sang, yes, Rory Sang.
No, sir, we haven't done area. We're still busy with geometry lines.
Okay, not a problem. Let's look at the chat and see who's done area. Yes, thank you, Zumbewe, as well as Tosley, Swanello. The area is length times breadth, or just length times length in case of a cube, right? So area of a square, I'm going to say length times breadth, but a side times side is also good. So you can say either side times side. Length times breadth, or side times side, right? Okay. Length times breadth or side times side. Either one is fine. But we see, remember our question here, we've got 3 centimeters for each one, right? So each one is 3. So it's 3 and 3 and 3 by 3 by 3 by 3 by 3. So it will be 3 times 3 for each one. And if we had to work out the area of the whole shape, the surface area of the whole shape, we would consider how many sides are exposed and things like that, right? So for each square, it would be 3 times 3, right? So this is our main focus. For square, it is 3 times 3. So area of square would be 3 times 3. So area of a square, one square. Remember, this is square, not prism. Square. So area of a square, side by side, side times side, or length times breadth. And in this case, it will be 3 times 3, which will be 9. And the units here is centimeters. So it will be centimeters squared. Squared, centimeter squared, right? So length times breadth, centimeter squared. Okay. Any questions regarding the area of a single square? No questions? Okay. Now, this is area, right, of a single square. But if we look at the cube here, how many sides of the cube are visible to us? So when we're looking at this cube, how many sides can we, if we walk around the cube, how many sides can we see on the surface?
Three.
3. And which would those 3 be?
Front, side, and top.
Okay, so currently you're seeing the front side and top. Now, if you hold this cube in your hand and you rotate it, have any of you held a cube in your hand? I'm sure you've held a cube or Lego piece or something and you've rotated it. How many sides can you then see if you rotate it round and round?
Four.
If you rotate it, isn't it 6? Because it's the front, the back, the side, the top, and bottom. Hey, it's one Elo. Thank you. Yeah. So it is 6. So if you take this cube and you move it around, you'll have 6 sides, won't you? Yeah. So if you're looking at something from the front, maybe you won't see the sides. But if you rotate something, the total surface area of something would be the total area around this cube that you're moving. So it will be 6 sides. So how will we then find the total area? We will say length times breadth, or side times 6. Yes? Okay. So the total surface area, I'm going to say total surface area. Let's get this marker running. So we've got total surface area. Surface area would be side times side times 6, because you've got 6 sides, eh? And side times side was 3 times 3. So it will be 3 times 3. So it's 9 times 6. And what is 9 times 6? 54. Okay. So it has 6 sides, and that's how we find the total surface area of the cube. Because we've got 6 sides here. Eh? Let's label them. We've got 6 sides. And it's going to be each side is 3 times 3. And we times it by 6. Therefore, we will get 54. KK, is this okay? Okay. And this is a cube that we can rotate. We can rotate this cube. So we can see all 6 sides, right? Okay. Okay. Are there any questions? Nope. Okay. So the parts that we focused on are cube, which had all 4 sides equal. We had the rectangular prism. We had the triangular prism. And you gave me some other examples, right? But these were the main ones that we focus on. The cube, the rectangular, and the triangular prism, right? And we will be looking more into all these shapes. However, it's important to understand the nets of each one, how to take the shape and break it down into the nets. So let's have a look at those nets again. We've got the cube. Here's the net for the cube. We've got the net for the rectangular prism. Okay, so that's the rectangular prism, and you need to understand the different sides. And we've then got the net for the triangular prism. Okay, are there any questions? Rory-san?
No, sir.
Okay, so we're going to stop there for today then. And anybody else, any questions?
No, sir.
No, okay, great.
No, sir.
So we're going to stop there for today. And yeah, I'm going to hand you over to Coco, who's going to tell you about where we're at.
Hello, everybody. So nice to see so
Hi.
many of you guys with us here.
Um,
Hello, everyone. So I'm just going to share my screen quickly so I can show you the homework that we've got going. Okay. So we do have something extra that we want to introduce to you guys today. My screen is not sharing. What's going on? Let me try that again. Oh, there it is. Okay, there we go. Okay, so this is what we've been doing so far. And let me just present quickly. Okay, we've been looking at these 3 topics. So today is the 13th of September, and we were looking at classifying 3D objects. And on Wednesday, we're going to be looking at angle relationships. So you guys are going to be doing a lot more calculating in the next class. So you guys better be ready with some paper and some pen. You're going to be doing quite a bit of that in the next lesson. Okay, so the homework that we're going to be looking at in this, for this chapter is you're going to go into surface area and volume. And if you click into that topic, you'll see it's going to say geometry of 3D shapes. Now, I want you guys to focus on the top part because this is exactly what you guys have been doing in this lesson, looking at counting faces and edges and 3D shapes. But then if you look at rectangular prisms, they also go through the surface area of the cuboid and a box and a rectangular prism like you just did with Teacher Depeche. So you guys can have a look at that as well. Okay, one last thing, and I'm just hoping to get like a yes, ma'am, like you can unmute and say yes, ma'am, or you can put your hand up. I just want to see, guys, how many of you guys would be interested if you guys could invite just one friend into our Zoom class to come see what it is that we are doing. Okay, you guys can raise your hands, or you can say yes, ma'am, or you can type it in the chat. I just want to see where you guys are thinking about this whole thing.
Yes, ma'am.
That
Yes,
is
ma'am.
awesome. Okay. That is amazing, guys. Thank you. Okay, so for those of you who haven't put your hand up yet or didn't write in the chat, think about it, think long and hard, and then you guys are gonna have to tell us which one friend you would like to invite. They're going to be able to join us for just one class. It won't be every class. If they want to join us for the other classes as well, they're going to have to sign up for the gold package like you guys have. But they'll be able to then come to our class and they can see what you and Teacher Depeche do every Monday and Wednesday. And yeah, get to enjoy the class with you guys. But then you need to remind them that it's a sneak peek. And if they want to come back again, they're going to have to tell their parents about it. Okay. All right, guys. Thank you so much. That is it from us for today. We're going to see you guys all on Wednesday at 5 p.m. All right, guys. Bye-bye, everyone.
Bye.
Bye.
ma'am. Bye, sir.
Take care, everybody.
Bye, ma'am.
Bye,
Bye,
ma'am. Bye, sir.
Bye-bye.
Bye.